Gravity, an introduction. The story goes that Sir Isaac Newton was sitting under an apple tree when an apple fell from above and landed on his head. Although the story may be more fiction than fact, Newton's theories and explanations surrounding gravity opened up an entire new world of thought. Despite the advances of some of the greatest minds in history, gravity is still not completely defined and remains one of the universe's biggest mysteries. However, an introductory knowledge of this omnipresent force surrounding us can be gained through simple historical experiments and observations. Like the Greek philosopher Aristotle, most people would believe that heavier objects fall faster than lighter objects. In this scenario, with a feather and a rock, that belief may appear true but is in fact false. The reason why the rock reaches the ground first is due to greater air resistance on the feather, which acts invisibly on all objects where air is present. Take the skydiver for instance. He accelerates downward caused by the force of gravity, but at a certain speed, the force of air pushing against his body is equal to the force of gravity pulling him down, therefore stopping his acceleration. Remove the air, and he again begins to accelerate. This example is to show that gravity affects all objects equally, regardless of mass. Galileo provided this concept through his famous Leaning Tower of Pisa experiment. The air affects both of these balls equally, not only because they are the same size, but one is heavier than the other. When he dropped them, they reached the ground at the same instant. Gravity also affects all objects equally, regardless of horizontal speed. In a perfect airless environment, if a cannonball is fired horizontally, as one is dropped from the same level, they will hit the ground at the same time. But where does gravity come from? Gravity is believed to be caused by all objects of mass, but because the planets and the sun are so massive, they are the most powerful gravitational forces. Through Einstein's theory of relativity, he predicted the actual behavior of gravity and how it affects the universe. Pictured here, a flat surface represents a three-dimensional space. As a large object passes over, its extreme mass warps the very space around it. This causes nearby objects to fall towards it, much like the effects of a bowling ball on a trampoline. Looking towards the future, as we learn more about our surrounding universe, we will likely develop a greater understanding of gravity and possibly unlocking its biggest secrets along the way. Who knows? One day soon, we may see faster-than-light space travel or levitating vehicles, which are now only ideas from our wildest imaginations.